we are looking at what's called non-parametric statistics. And these techniques are used when your traditional methods don't apply. Maybe you don't meet the conditions of a normal distribution, for example. And because we're not necessarily working in a normal distribution, if you had an approximately normal distribution, your measures of center should all be about at the same spot in the center. But you guys know in a skewed distribution, the mean will move in the direction of the tail, but the median will stay more towards where the bulk of the data is. And that's why a lot of these tests, you are now doing inference about the median instead of the mean. So this one is a matched pairs sign test. So it best equates to when you did literally a matched pairs test back when we would do a t distribution. So in this one, though, what we're going to do is we're going to test the equality of two population medians. The idea behind the Wilcoxon Test is to first compute the differences in the matched observations, and then you rank the absolute value of the differences from smallest to largest. So I have one tiny little example here just to show you. So let's say this is the first set of data, and here's the matched pair. So you do your subtraction, often based on which one is proposed to be larger or smaller. But when you do the rankings, it almost doesn't matter, because after you do the subtractions, you're going to take the absolute value of all those, and then you rank these numbers from smallest to largest. Now, if it comes out to be 0, you'll notice I marked that one as don't worry about it, okay? So you would just say that difference came out to be 0, they were identical, so I'm not going to worry about that one. But then, if you have two values that are the same, basically without this one, there's only 4 values left. So you can't rank either one of these as 1 or 2 because they're the same. So what you do is you average the rankings of 1 and 2, and they both get a number of 1.5. So one of these counts as 1, one of these counts as 2, and then this would be 3, and this would be 4. So that's actually where it starts, is this would be 1.5 and 1.5 to represent first place, second place, third place, fourth place. And after you rank them, then you go back and say, but by the way, this one came out to be negative. This one came out to be negative. This one came out to be positive. This one came out to be positive. So after you rank them, then you go back and put the plus and minus signs back on, okay? Not hard, but even I, after a couple of years of doing this, it's like I just, tiny little details like that. It's like you got to subtract, absolute value, rank, and then put the positives and negatives back in, okay? Details regarding the test statistic for small samples are provided below. Now, small sample here is n less than or equal to 30. I think so far in the tests that we've done, one of them was small sample had to be less than 20. Then there was 125, and now this one's 30. You are still going to be doing left, right, or two-tailed tests. Okay. Now it says M sub D, because M is going to stand for the median, but D is going to stand for the difference, because once we subtract, we're going to be working off the values from the subtraction. Your test statistic is called T. You are still going to be counting positives and negatives, but now you don't just count how many positive and negatives, you count the value. So this would be a value of negative 5.5. And this would be a value of positive 4.5. So you don't just say, well, there's 2 negatives and 2 positives. You actually get the total of how much negative and positive. And that's why we call it T this time, okay? If it is a left-tailed test, you're counting T plus. If it's a right-tailed test, you're counting T minus, but then you're going to take the absolute value. If you're doing a two-tailed test, you take the smaller of the two, okay? You're going to use the table again. It's going to be the next table in your packet. So we've already used table 9. We already used table 10. We are going to now be on table 11, which is the Wilcoxon signed ranks. It's labeled so you'll know which one to use, okay? You will reject if your T is smaller than your critical value, meaning that the sum of the rankings is much smaller than you would have expected. Large samples, you can do a Z calculation again, and then use your normal CDF. But because of where we are in the school year, and because all of these start getting a little bit more complicated, in this case, we're going to do just small samples, okay? So I put this here just so you could see it, but I put an X here. We're not going to be doing large sample cases here, okay? All right, so example 1, small sample. A stock analyst read a report stating that the median daily volume of JDS Uniphase, whatever that is, was the same as Nortel network. The analyst felt the median daily volume from JDS was greater than Nortel. To test his claim, he randomly selected 14 trading days, recorded the volume of stock for each, and obtained the data in millions of shares, table below. Test the analyst's claim at the 5% level of significance and assume previous analysis shows that conditions for parametric traditional measures were not met. So this is another one of those tables that the way it's written here, you have to actually imagine that all of this is in one long column. Okay, so there's 14 numbers for Nortel, and there are 14 numbers for JDS. Okay, so how I do this, and I forgot to bring my calculators over. And if you want to enter the data in your calculator, you can. If you want to just watch me, that's fine. I already have it pre-entered to save us some time. Okay, so I'll start with, I'll do this on my 84. All right, so I have the data in columns 1 and 2 for Nortel and JDS. Okay, so if you look at these two columns, don't worry about the data over here. These two columns, hopefully I have the data entered correctly. So this is how I do it. And when I get to my Inspire, if I mess up, forgive me, because you guys know I'm not as good on my Inspire. But what I do, I know I'm going to be subtracting. Now, which way do I want to subtract here? JDS greater than Nortel. All right, so what I'm going to do is I'm going to do the difference of JDS minus Nortel. Okay, so that's actually what I'm going to do in my calculator right now. So in my calculator, now JDS is the second column. So I'm going to make a third column, and I'm going to define it as my L2 minus my L1. Okay, so there are the subtractions right there. But actually what I need in order to rank them, I don't want any negatives. So actually what I'm going to do is I'm going to go into the next column, and I'm going to take the absolute value of that third column. So on an 84, for me, the easiest way to get to absolute value is I just go to my catalog down here, and alphabetically, it's the first thing in the catalog. So I'm going to say take the absolute value of what's in L3. Okay. So I subtracted. Now I took the absolute value, and now what I'm going to do is I'm going to override column L4. So I'm actually going to go to stat, and I'm going to sort. And I'm going to sort L4. And it says done. So now when I go back to my data, when I look at L4, I now have all these subtractions, and they're all sorted. Okay, so I usually do, by the way, I usually take the time to write down a subtraction column. Okay, so I actually would have written down, I would have said, what is J minus N? Okay, so those all came out to be, and this is just me copying down what's in L3. So 14.5, 12.1, 5.3, 4.2. Now that one was negative. I'll put that there. 21.6, 14.3, 14.2. Now this is just me. I like to write it down. To be honest, you don't even have to, I don't think. You'll come up with your own ways to be. I don't like how that looks. That's messy. 22.9, 19.3, 56.7, 14.9, and 9.6, and then there's a 37.1. Okay. You also could have written it down in order if you wanted to after it was sorted. Doesn't matter. But what I do then is I go through and I make a second column, and now I call this the ranking. Okay. So what I would do now is I can look at this and say that in my rankings from the very top here, okay, so this got ranked number 1, okay, when I sorted it. And then I can actually go through, this got ranked as number 2. This got ranked as number 3 and number 4. And I go through and I literally make my list. I let the calculator sort it. Now this is where I said, you'll come up with your own ways. Some people don't even bother entering in their calculator other than doing the subtraction. They just kind of look at this and they're just like, okay, what's the next one? What's the next smallest number? I let the calculator sort it, but eventually what I have is there's an 8 here and a 5 and a 3 and a 2, 11, 7, 6, 1, 12, 10, 14, 9, 4, and 13. So you rank them without the negatives.
Attention teachers and students, if I can have your attention for just a moment. In just a minute, students who were invited to the PACO Senior Honors Night this evening will be released to take part in a 15-minute run-through of the evening's event. There's some important information that we want to share with students to help make this evening successful. For teachers, if you would, using the list that we gave you yesterday, please send those students who are invited to the JPAC now.
Hey, you guys know done JPAC. It's supposed to take about 15 minutes. So, all right, so after you sort them according to the rankings, what you do now is you go back and you put the negatives on the rankings where the differences were actually negative to begin with. And so when we have a T sub-negative, so you actually want this total. So T sub-negative is -3. T sub-positive is going to be, and you're going to add up all of these other numbers, which I have T sub-positive. You know what? I don't even think I added it up because this ends up being a two-tailed test. So you want to use the smaller of the two. And I can see when I add all these up, it's going to be something larger than 3. And I say larger than 3 because if your T sub-negative, you want to take the absolute value of that. So your T sub-negative is 3. All right, so I kind of skipped the hypotheses. You probably ought to go back and fill that in. Your null hypothesis. Your null hypothesis, again, is generally that there's no difference between the two. But because we set it up as a difference, we are going to set it up as the median of the difference is 0. The alternative hypothesis is that the median is, let's see, what are we saying here? We are saying that JDS is greater than, so we set it up like this. So we would want a greater than 0 here, where M sub D is the true median difference between JDS and Nortel shares. We don't have to worry about conditions. We're not going to even get into all that on the test. You won't have to do conditions. I would expect you to be able to set up the hypotheses, including this, know how to go through and do the sorting and the calculations. And now we look at our table. We have an n size of 14. So I look at my table and we are doing a 5% level of significance with an n size of 14. We have a critical value of 25. And this is from table, and we're on table 11. All right, so basically what we're saying is 25 is our cutoff value here. So since we came up with 3, basically you're going to say, is T smaller than CV? Is 3 smaller than 25? Yes. So we are going to reject the null hypothesis, and we are going to conclude in context, we have sufficient evidence at the 5% level of significance to reject the claim that the median difference is 0 in favor of the true median difference is greater than 0. So in some ways, you're still saying the same thing as you said in the old test. You're saying that JDS has we wish we could say has a larger mean share, but because we perhaps didn't satisfy the parametric procedure conditions, we're now going to be talking about the median, okay? So how you do this, like I said, it's up to you. You'll come up with your own way of doing this. You can see my work here. I've done it all by hand many times, but I'm trying to come up with ways to shortcut it in the calculator a little bit, where you can let the calculator do the subtractions and then sort it for you. When I try to sort on my own, I'll start saying, okay, there's number 1, there's the second one, there's the third one, and then all of a sudden I realize, oh great, I missed one. And then I have to go back and renumber. So I'm trying to come up with better ways to let the calculator help us a little bit. All right, so I have a second example here. The table below shows the hours of relief provided by 2 analgesic drugs in 12 patients suffering from arthritis. Okay, so N is 12. Is there any evidence that one drug provides longer relief than the other? So this would end up being a two-tailed test, because we're not saying that A is better than B or B is better than A. We're just saying, is one better? So I will start by saying that my null hypothesis is that the median difference is equal to 0, meaning there is no difference between drug A or drug B. And my alternative hypothesis is that the median difference is not equal to 0, meaning one might be greater than the other, but I don't know which. So in this case, it really isn't going to matter which way I subtract. Where in the last one, we definitely were trying to claim that J was greater than N. But here, it probably doesn't matter. So I put these in my calculator, okay? I put these in, and I just did, in my calculator, I did A minus B. So I did drug A minus drug B. And I got the value of 1.5, and these are pretty easy just to do in your head. 2.1, 0.3, 0.2, and basically all you're doing here is you're just saying how far apart are they. You don't have to worry about which is positive and negative yet, okay? So literally just talk about how far apart are these. 6.6 to 6, they're 0.6 apart. These are 1.5 apart. These are 2 apart. This one would be 2.3 apart. And then this one would be 12.4 apart. Don't even worry about positive versus negative. And that's where in the directions it'll say take the absolute value. You want to just find out how far apart the values are. And then you're going to rank these numbers. Okay. So you could go through and rank it as, all right, what's the smallest number here? That definitely looks like the smallest. Okay, what's the next smallest? What do I have here? 0.2, 0.3, 0.6 would be 4. All right, here we go. There's two 1.5s. So we can't call one of these 5 and one of them 6. So we just average 5 and 6 and we call them both. They just both get a 5.5. But call it 5 and 6 as you're counting in your head, because then the next one becomes 7, which is right here. And then I have, this is 8 and 9 and 10. And 11 and 12. Yeah, I just looked at mine. I was like, I have those numbered backwards there. It doesn't really matter, because the bottom line is, at this point, now you have to come back and say, okay, well, which of these were supposed to be negative if I did A minus B? Well, then this one would have been negative. So call this a negative 5.5. So I'm going to find any place where A was smaller than B, and I'm going to call those negative. This would be a positive. So I go through and mark. So this would be a positive, negative, 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 negative. All right, so we need a T sub negative, and we'll need a T sub positive. And on a two-tailed test, we're going to use whichever one of these is smaller. But remember, this one, you take the absolute value. So you would literally have to add up all of your negatives, which I have all of the negatives actually add up to negative 71. So call that 71. And when you add up all of the positives, that adds up to only 7. So you use that one. You always use the smaller of the two. If it's a right tail test, you use the T sub negative. If it's a left tail test, you do the T sub positive. If you end up doing a two-tail test, you do them both and pick the smaller of the two. So this is going to be our critical value, or excuse me, our test statistic. We have an N size of 12. Now on this, it says do a 5% level of significance. However, for a two-tailed test, take that alpha and divide it by 2. So you are going to be looking at 0.025 instead. So the table was created assuming that you're looking at half the tail on one end and half the tail on the other, and the two tails together have to add up to 5%. So I'm going to look at my chart. N is 12. I'm going to look at the 2.5% column. My critical value is 13. So my critical value equals 13. And I'll remind you again, that comes from table 11. So you come down here and say, is T smaller than my critical value? Is 7 smaller than 13? Yes. So once again, we are going to reject the null hypothesis. And we could conclude we have sufficient evidence at the 5% level of significance to reject the claim that there's no difference between the two drugs, in favor of there is a difference between the two drugs. Now, which one do we think? Okay. This is the hours of relief. Okay. So in general, you think about which one looks like it's providing more hours of relief. It sure looks like drug B is. But all we know is that there is not a difference, or rather we think there is a difference, but we don't know for sure what it is. But my hunch would be, and maybe what someone would do now is maybe they would actually do a one-tailed test and make sure that it's significant at, that level. But that's the Wilcoxon right there. Okay, and you only have to worry about small samples here. We won't do a large sample. Reminder on the test, no multiple choice. You will be given a formula page. Obviously, you have your calculator, and you're just going to be going through the different tests. And I'm even going to, I'll be nice. They're going to go in order. Okay, we're just gonna kind of go in order that we learned them, which means you'll be using the tables in order, okay?